Welcome back to Joy in Mathematics. This is a platform that seeks to establish understanding mathematics, and I am your tutor, Ejalon Budevi. So let's continue on our series of videos on vectors. We have considered two exercises that involves addition and subtraction, scalar multiplication, and also magnitude of vectors in their component form of unit vectors. So now let's look at what we call unit vectors. Now, a unit vector is simply a unit vector is a vector with magnitude of 1. Is a vector with magnitude of 1. Now, I'm sure you're familiar with some unit vectors that we have. We have unit vector I, we have unit vector j, and we have unit vector k. I is simply written as 1, 0, 0. Okay, j is written as 0, 1, 0. K is written as 0, 0, 1. So if you convert this to component form, so this will have 1i plus 0j plus 0k. If you take the component or the magnitude of this vector now, let's call it vector I, this will be the square root of 1 squared plus 0 squared plus 0 squared, which will be square root of 1, which is equal to 1. So we can say that it is called unit vector because the magnitude is equals to 1. If we do the same thing here, we will have the magnitude of j to be equals to 1, magnitude of k to be equals to 1. Now, what if we don't have I, j, or k? What if we have a vector R that says it is a vector of xi plus yj plus zk? What is the unit vector? Now, to evaluate the unit vector here, most of the times, okay, before we continue, most of the times the unit vector are written with a cap on it. Okay, I, j, k, I, j, and k. So to evaluate the unit vector of this, we have a cap on it, written on it, and the formula, it's simply having the vector itself being divided by the modulus of the vector. Okay, so we have the modulus of the vector to be equals to the square root of x squared plus y squared plus z squared, and this is the vector itself. Therefore, we can simply say, okay, that our unit vector, which is the R with the cap on it, is equal to the vector itself, which is xi, right, plus yj plus zk divided by the magnitude of the vector, which is written as x squared plus y squared plus z squared. Similarly, if it is a two-dimensional vector, let's call it vector p and say it is equals to ai plus bj. The magnitude of the vector p is given as ai a squared plus b squared, and the unit vector of p with a cap on it will be equal to the vector itself divided by the magnitude of p, which will be equal to ai plus bj divided by the square root of a squared plus b squared. Now let's take some examples. Question 1. We are asked to evaluate the unit vectors of 2i plus 3j. So now you can pause the video, give it a trial, and let's see what you have. All right, let's continue. So 2i plus 3j, this is a two-dimensional vector. So let's call this vector A. Okay, vector A. Now, once to evaluate the unit vector, that is A with a cap, that means it will be equals to the vector itself divided by the modulus of the vector. The modulus of the vector is mod A. So the modulus of the vector here will be the square root of the sum of the individual squared, and that will give us the square root of 2 squared plus 3 squared, right? And this will result into the square root of 4 plus 9. That's equals to the square root of 13 units. All right, so let's substitute now. That's A itself. Unit vector is A, the vector itself, that's 2i plus 3j, divided by the modulus of the vector, which is equals to root 13. Now with that done, we can simply write the unit vector A with the cap on it to be equals to 1 divided by root 13 multiplied by 2i plus 3j. Easy. Let's take another example. Question 2. We are asked to evaluate the unit vector of vector B. Let's say the vector B is given as 4i minus 5j. Now you can pause the video again and solve this question. And let's continue. We are asked to evaluate the unit vector of B, and that will be equals to the vector of B divided by the modulus of B. The modulus of B is given as the square root of 4 squared plus minus 5 squared, and that will give us the square root of 16 plus 25. And the square root of 16 plus 25 is equals to root 41 units. So with that done, the unit vector B will be equal to the B, that's 4i minus 5j, divided by modulus of B, which is 41. And this will result into 1 divided by root 41 multiplied by 4i minus 5j. And this will be the unit vector of B. Now, it can also be three-dimensional vector. We have dealt with 2 dimension, we also done 2 dimension. Let's take for 3 dimension. Okay, now let's take, for instance, we have a vector C of 3 dimensional to be 2i minus 5j plus k, and we are asked to evaluate the unit vector of C. The unit vector of C therefore will be equals to the vector itself, vector C itself, divided by the modulus of C. Now this means that the vector itself is 2i minus 5j plus k, and then the modulus of C, which we'll have to evaluate, will be equals to the square root of 2 squared plus minus 5 squared plus 1 squared. With that being simplified, we have it to give us square root of 4 plus 25 plus 1, which will be equals to root 30. Now, since we have root 30 to be the modulus of the vector, we can conclude that the unit vector of C will be equals to C, 2i minus 5j plus k, divided by the modulus of C, which is root 30. And we can rewrite this to give us 1 over root 30 into 2i minus 5j plus k. Let's take another example on unit vector of a 3-dimensional vector. Let's call this vector D. Now vector D now is equal to I minus j plus k, and we know that we are asked to evaluate the unit vector of D, which is equal to the vector itself divided by the modulus of the vector. So the modulus of vector D is the square root of the sum of the individual squares, that's 1 squared, okay, plus minus 1 squared and plus 1 squared, and this will result into square root of 1 plus 1 plus 1, that's root 3. So therefore the unit vector of D is equals to vector D, which is I minus j plus k divided by root 3. This can be written as 1 over root 3 into I minus j plus k. So that is how to evaluate unit vector of a particular vector. So if you have R to be a vector or the unit vector, it's given as the vector itself, R, divided by the modulus of the vector. In our next lesson video, we'll look at more applications or how to solve unit vector given a more complex question.